Okay, so let's talk about early thoughts on atomic structure, and this should take us up to about modern day. So here we go. Empedocles was a philosopher in Greece well before the current age. He lived before Socrates, and he was the first to invent the idea of four classical elements called earth, water, fire, and air. Ether was considered a void or lack of substance, and he proposed that life and strife could mix with the elements to separate them. All of his writings were in poetry form, very long poems. Democritus was next. He lived a little later, and he chose the word for atom. His name means chosen of the people. He proposed the idea of atom, which meant the smallest individual particle that could not be divided. He was a contemporary of Plato and Aristotle. Aristotle disagreed with him, and therefore his theory was not accepted. Aristotle was a philosopher along with Plato, and he was considered to be the father of modern or Western philosophy. At either 17 or 18, he joined Plato's Academy in Athens. He remained there until he was 37. He had writings on physics, biology, zoology, metaphysics, and much more. Shortly after Plato's death, he became Alexander the Great's tutor, and he established the library in the Lyceum, and he disagreed with Democritus. So these ideas fell out of favor until the early or mid 1700s, and John Dalton was the next one to take up this idea. He's best known for his atomic theory and his research in color blindness. He was born into a Quaker family. He received an early education from his father and another Quaker, John Fletcher. He went into service for a local Quaker, and he began teaching at a local school at age 12 and was proficient at Latin at 14, and he was headmaster by 18. So his atomic theory had 5 points. Some of them have been revised, but the whole idea of it was very well received. So, elements are made of extremely small particles called atoms. Atoms of a different element are identical, or of a given element are identical in size, mass, and other properties. And that has been revised. So anything you see here in bold or italics has been revised. Other properties of atoms, atoms of different elements differ in size, mass, and other properties. Atoms cannot be subdivided, created, or destroyed. We know they can be subdivided, and that's what happens in a nuclear explosion. Atoms of different elements combine in simple whole number ratios to form chemical compounds. This is called the law of mass action. In chemical reactions, atoms are combined, separated, or rearranged. So, this gave rise to the law of definite composition. A given chemical compound always contains a component element in a fixed ratio that does not depend on the source. And this is the basis of stoichiometry. A second law that comes out of that is the law of multiple proportions. If two elements form more than one compound, between them the ratios of the masses of the second element, which combine with a fixed mass of the first element, will be a ratio of small whole numbers. That would be like H2O and H2O2. Both would have the same mass of hydrogen but different masses of oxygens, and those oxygen masses would be in whole number ratio of 1 to 2. So Faraday, he invented the Bunsen burner. He also discovered benzene, and he developed a system of oxidation numbers, or what we see as charge. And he did experiments with an anode, cathode, electrode, and an ion. So he developed ion, or he did experiments with ions. J.J. Thomson discovered the electron and is the first subatomic particle to be discovered. He used a cathode ray tube. They are composed of electrons and those particles have a negative charge. He calculated the mass of an electron using the charge to mass ratio. He found the first evidence of isotopes as well. However, he did not go fully with it. But his work led to the development of the mass spectrograph, and he won the Nobel Prize in 1906 in physics. Millikan also won the Nobel Prize in 1923, and no, you don't have to know any of the dates, for his work on the photoelectric effect. He determined that on the charge of a single electron. To do that, he used an oil drop experiment in 1910. The photoelectric effect is the emission of electrons or other free carriers, charged carriers, when light shines on them. Electrons emitted in this manner can be called photoelectrons or photons. Ernest Rutherford is the father of nuclear physics, and he did an extensive work in radioactive half-life. He won the Nobel Prize in Chemistry in 1908, and he used alpha and beta radiation, and his gold foil experiment helped to determine that the charge of the nucleus is positive because he used alpha particles, as you can see over here in this drawing. Alpha particles hit a thin foil. Most of them passed through, but some of them were deflected a little bit, and some of them were greatly deflected, and that's because as the charged particles came close to a gold nucleus, it would be deflected slightly. If it came directly in contact, head-on collision with the nucleus, then it was greatly deflected. The earlier model of Thomson, which was the plum pudding model, felt that all the particles should go straight through. However, that was not the case. So, Niels Bohr won the Nobel Prize in 1922 in physics for his atomic theory and quantum theory. He developed the Bohr model of the atom. We still use this idea, however, we know it's much more complex than this. He proposed energy levels are discrete, that an energy level would be either energy level 1, close to the nucleus, 2, somewhat further away, or 3, even further away, and that electrons only exist in these discrete orbitals. They are not in any region in between the two. So they can jump from a lower energy to a higher level, and that would take the input of energy. If they go from higher energy to a lower energy, then they give off energy that is some multiple of this energy level, and that's what N stands for. So the underlying principles remain valid, although it has been modified. Heisenberg, 1901 to 1976. He is one of the key pioneers in quantum mechanics, and he is known for the Heisenberg uncertainty principle that he developed in 1927, and he won the Nobel Prize in Physics for his creation of quantum mechanics. And the uncertainty principle says that the more precisely we know the position of a particle, then the less precisely we know its momentum, and vice versa. So if we accurately determine its position, then its momentum changes, or if we know its momentum, we change its position. You should know the Heisenberg uncertainty principle. Schrodinger's cat. Yep. And he was one of the first ones to form the basics of wave mechanics and quantum theory. He actually developed new math called a wave function, a wave equation, to help describe the motion or position of electrons. And Schrodinger had a thought experiment about Schrodinger's cat, that the cat is both alive and dead inside a box, and you can look it up and read about it. It's kind of interesting. And he did win a Nobel Prize in physics for his wave function or wave equation. Chadwick. So now we have that the positive electron, the positive nucleus, we have electrons, but we haven't yet discovered the neutron, which is what Chadwick did in 1932. And he used MAUD report inspired the U.S. to begin serious atomic bomb research. And he worked on the Manhattan Project with a few other very well-known physicists. And so he was able to discover the neutrons because he would separate the neutrons from the protons, and he realized that some of the particles were missing from what was given off, and so those particles had to be neutral. They were much more difficult to detect than the electrons or the protons, because electrons and protons are positive or negatively charged, so they're easier to find. You need to know some major early experiments. I've already described most of these, so I'm going to just kind of flash through these. At this point, you would want to stop and read what's on each slide. You need to know the cathode ray tube experiment. You need to know that it was J.J. Thomson. You would want to know what particle he discovered and how he discovered it. Then Millikan oil drop experiment. Again, you need to know the person. You need to understand what he did and what he found out from that experiment. Thomson proposed the plum pudding model of the atom, which was quickly disproven by the gold foil experiment by Ernest Rutherford. And so again, you would want to go through this. I'm not going to stop and go through each. I'm sure you can read it for yourself. And on the right is a quote from Rutherford regarding his experiment. Neutrons were the most difficult to detect because they have no charge. Protons accounted for only half the mass of an atom. Chadwick discovered them in 1932. And the mass of a neutron is relatively the same mass as a proton. And that gave rise to the idea that isotopes can have the same number of protons, which gives us the identity of the element. But then the neutrons can be different, which would give us different masses for different isotopes. So that's it. Thanks.